Now we're going to move on to talk about factorials. What a factorial is it's an expression written in this form, and we call this a factorial, but it looks like an exclamation mark. And what it means is take that number and then decrease that number by 1 until you get all the way down to 1, and take all those numerals and multiply them together. You can see right here that 4 factorial is the same as 4 times 3 times 2 times 1, which is 24. And by definition, 0 factorial is defined to be 1. If I want to simplify 6 factorial over 3 factorial, that's not necessarily 2 factorial. It's 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, which in essence is 6 times 5 times 4, or 120. To get n minus 4 factorial over n factorial, keep in mind n factorial is n times n minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5 until I get down to 1. N minus 4 factorial is going to start with the n minus 4 term. And then I take 1 from that and multiply it. So that's n minus 5. Then I take 1 from that until I get all the way down to 1. You'll notice everything from n minus 4 down to 1 is going to reduce with a like term in the denominator. So this term goes here. Let's do it in green so you can see it a little better. These are the same. These are the same. And then everything all the way until 1 is going to be the same. So those will all reduce, leaving me with an expression of 1 over n times n minus 1 times n minus 2 times n minus 3. And that's how that reduces out. When we talk sigma notation, this is a Greek letter sigma here. And in math, it means the sum of, or find the sum of. And a typical sigma notation setup is the following, which says as n goes from 1 to n of a sub n, add everything up. In other words, find the sum of this series generated by the equation of a sub n. This will typically be an explicit formula, where n begins at 1 and increments by integers of 1 until it reaches the value n. Let's go in practice because this is a little touchy-feely and out there right now. So here's a couple examples of a sigma notation sum. This says find the sum of the series that is made by n starting at 1, plugging it into the formula, incrementing by integer values of 1 until I get to 6. So let's do that. I have 5, and n starts at 1. Then I increment by 1 and say 5, and n equals 2. 5 times n equals 3. Whoops. N equals 3. 5 times n equals 4. 5, n equals 5. And 5 times n value is 6. This gets me 5 plus 10 plus 15, etc., etc. Until I get to 30. I add all that up. We got 30, 50, 80, 105. And that is the sum of that sigma notation problem. Let's do it again here. You'll notice my n value doesn't start with 1. It doesn't have to. It can start anywhere you want it to. So in this case, we start at n equals 4, and I have 2 to the 4th plus 1. I increment by 1. I have 2 to the 5th plus 1. 2 to the 6th plus 1. And 2 to the 7th plus 1. And then we have to add all those quantities up. And I end up with about 244 after I plug that into a calculator. So next we're going to express a sum using sigma notation. And you'll notice I need an explicit formula to generate this pattern right here. So I'm going to need to plug an n equals 1 in to get this number out, n equals 2 to get 6 out, n equals 3 to get 9 out, and n equals 4 to get 12 out. That's the way I choose to do it. So you'll notice this isn't too hard to generate. Our nth term is basically equal to 3n. So if I say I want to add the terms generated by the sequence of 3n as n goes from 1 to 4, incrementing by 1, that will generate that sum. Let's do it again. A little bit more difficult set of terms to generate, although really not too bad because we can see n equals 1 here, n equals 2 here, n equals 3. And you'll notice that the pattern is squared terms. So this is n equals 10. And therefore, if I want to add the sequence of 1 over n squared as n equals 1 to 10, this will generate the following sum. Let's continue. Here's another one. I want n equals 1 to generate the first set, n equals 2 to get the second, n equals 3, the third, n equals 4 to get the next. And we've done a couple of these already. You'll notice I need 2 and 3 on the top. So my nth term would be n plus 1 times n plus 2. That'll generate 2, 3, and then 3, 4, and 4, 5, and 5, 6. The bottom we've kind of seen before. If we square each term and add 1, that will generate my denominator. So I only got 4 terms. I'm going to let n equal 1 to 4 of n plus 1 times n plus 2 over n squared plus 1. And I think that's probably the easiest way to get that problem done. Couple more. This next one's a little more difficult. We haven't seen this. The top, not too bad. The denominator is going to be a little more difficult, and you'll notice we have that alternating positive and negative, so we'll have to use that power of -1 in here. N equals 1 has to get me a 4. N equals 2 gets me a 16. N equals 3 gets me a 64. N equals 4 gets me a 256, and this goes on forever. So what I'm going to have in this case is an infinite sum. I want to plug in 1 and go to infinity and get an nth term for this. So you'll notice on the top, these are powers of 4. 4 to the first, 4 to the second, 4 to the third, 4 to the fourth. So we have 4 to the n as my numerator. The denominator, 1, 2, 6, is kind of tough to see, although I can point out that this is multiplied by 2, multiplied by 3, multiplied by 4, and that, in a sense, is a factorial problem because this is 2 times 1, 3 times 2 times 1, 4 times 3 times 2 times 1. So when you see 1, 2, 6, 24, that's basically a pattern for n factorial. So let's go ahead and do that. And now the problem I have is I need a negative on my first term. So in order to get that negative, what I'm going to do is I'm going to multiply this fraction by -1 to the n power. Because what that'll do is it'll make my first term negative. My second term is going to be squared, so it makes it positive. Third term cubed negative. Fourth term, etc., etc. Now we're going to use a calculator to find the sum of the sequence. So here we go. What I first want to do is find the summation on the calculator. If I hit math and I move to the number, I believe it's 10 in this case, notice I get summation or sigma. I'm going to hit that. Next thing I need to do is plug in my formula. Now these say n, but I'm going to use x in this case. X cubed plus x squared. And then after you've written your formula, you're going to put a comma, followed by the variable you're using in this case, or the counter, and that's going to be x. And then you're going to tell the calculator where to start. We're going to start at x equals 1, and put a comma again, and you tell the calculator where to stop. We're going to go to 10. Close your parentheses, hit enter, and it will calculate everything for you. So the answer in this case is 3,410. And that's how you use your calculator to find a sum. That's all we've got. Fill out your summary, do your My Math Lab, and we'll talk tomorrow.